So, good morning, one and all present here. In today's lecture video, we are going to see about forward chaining and backward chaining. So, let me start with the slide number 17. Yeah. What is actually forward chaining and what is backward chaining? We will be seeing about the properties. First of all, we will see the definition of forward chaining and we will see about the properties of each and with the real-time example. So here, as the definition goes like this, it is actually a method of reasoning in AI in which we know about the inference rule, where we apply this rule for making perfect decision, so that you will be extract the data until your goal is reached. So what is the thing is, in this type of chaining, the inference engine, it will just start evaluating the existing facts, derivations and conditions before arriving to the new information. So here the goal is, that means the endpoint is achieved. How it is achieved is through the manipulation of knowledge that exists in the knowledge base. So this is the perfect diagram for forward chaining. Say for example, you have fact 1 and fact 2 and you are applying a condition here. You may end with the decision 1 and you are combining it, and at last you are arriving at here. And fact 2 same, similarly applying inference rule which derives in decision 1 and we are combining something. And fact 3, here we are using OR condition, and for fact 4 also we are using OR condition, and we have arrived at the decision 2. Comparing decision 1 and decision 2, or combining decision 1 and decision 2, we will have one more new solution or new information is decision 4. What is actually the properties of forward chaining? Here the process is down up approach, or we can say it as bottom to top. It starts from an initial state and uses facts to make a conclusion. This approach is data driven. It's employed in expert system and production rule system. A simple example here is, you have a sequence like A implies B and B. Say for example, assume that A is the starting point and A implies B is representing some facts. So this fact is used to achieve the goal called as B. So say for example, Tom is running, that is A. If a person is running, obviously he will be sweat, that is A implies B. So therefore we can conclude like Tom is sweating. That means what? He is already running. So this is the best example for forward chaining. And the next is backward chaining. Backward chaining, as the name called as, which involves backtracking. From the end we will reach to the from the end point or from the goal we can steps which led to the end point. This type of chaining starts from the goal and moves backward to comprehend the steps that were taken to attain this goal. So it's actually a backtracking one. So here the reverse case is here, as how we saw the diagram for forward chaining. From the decision we are just arriving to the facts. So let me see the properties of backward chaining. Here that is up-down approach, that means top to bottom. It's a goal-driven method of reasoning. The endpoint goal is subdivided into, we are just dividing it into sub-goals to prove the truth of the facts. It will actually employed in inference engine, or we can use it for game theories. And if we have some complex database system, this backward chaining is very useful. What is the main example for backward chaining is, here the sequence is followed here. B, A implies B and A. B is the goal or endpoint, that is as important. The same example, it is applied in backward chaining. Say for example, Tom is sweating So if a person is running, he will sweat. That is A implies B. So Tom is, the meaning is Tom is running. And we will move on to the third unit. So in the next video, we will continue with the third unit. Thank you.